Let's talk about variables in programming. What is all our variables? I am Robert. Let's follow along. So, in a computer, just like in any human's memory, we keep track of items that we will be using. So, think of a time where you meet someone on the road and then you exchange pleasantries. Hi, I'm John. And then the person also responds. Now, just after that interaction, you see the person's face, you get a person's name. You would want to recognize the person again the next time you meet him. And so, what will happen is in your brain or in your head, you are going to create a container, and on that container, you are going to put a picture, mental picture of that person on the container. And because you would want to be able to mention the person's name the next time you see him or her, you are going to put the name of the person in the container. So think of cream you bought at a cosmetic shop. On the label of the cream, you have a picture, and then inside the cream, that's the content of what you need. And so by seeing the container, which is a picture, by seeing the container, you see the picture on the container. And then inside the container, you are going to find the person's name. So when you meet Joan again, you will see the picture of Joan. And after seeing the picture of Joan, in your head, you will be scrolling through all the containers that have pictures on them in your memory. And the moment you see that picture, you will open that container and then try to find out, what's your name, Kra? And then because the name is inside the container, you are going to pop it up and then you say, hi, Joan. So that's basically what happens. Now, let me talk about variables. Sorry about the long story, but anyways, it was very important. The same thing happens with a computer. So variables are storage containers in a computer's memory, and then they are given special names. They store values during the execution of a program. Think of a time where you were using Microsoft Word. While using the Microsoft Word, the machine goes off. The moment you turn back the machine on, you've lost all the items you were typing on the Microsoft Word. We already know that the computer's memory is a volatile memory. And by volatile, we mean that anytime you are working on the computer, they store stuff on the memory. And the moment you are done with the program, it all goes away. After you turn on the computer, a lot of programs are running in the background. So you also decide to watch a movie, and so you start the VLC program. You want to watch a video, so you select a particular video file. While you are watching the video, it continuously plays. What happens in the background is for every program that is running with the VLC inclusive, a part of the computer's memory is reserved for it. Any activity you do with a VLC program is saved on the computer's memory. And because the memory is volatile, it doesn't keep items for a permanent time or a permanent amount of space. So what now happens is the small amount of memory that's allotted for the program will only be around while the program is still running. That's why you lose your Microsoft files that you don't save permanently. All right, let's continue. I will explain as I just did in the first scenario. So when a program is in execution, what really happens? When a user is interacting with a program, the user will first see something on the screen and he's going to respond with an input. So what is your name? Let's say a simple form. What is your name? The user would have to respond. Think of a time where you needed to fill a form at a bank. The banks have a statement. Okay, they have a sheet at the bank with which you will have to fill in the deposit, the check, what. They usually have labels, amount, and then you will key in some value. Okay, so that's basically what happens when a program is in execution. They show you something and you respond with an input. Based on your input, they will process and then show you another output. So basically, after input, the next thing that happens during the program execution is there is a processing. They will show you, you will respond, they will process, and eventually they will show you another output with which you will respond. It goes on and on and on until finally they would want to save what happened during the interaction. So these are the basic stuff that happens when a program is in execution. All right. Now we spoke about the fact that we have containers in our heads with people's pictures on them. And so the moment we see the pictures, we open the container, we check, oh, okay. So what's inside the container is John. So this guy with this face is called John. In a computer, when we interact with programs, they ask us to fill in our names. They ask us to choose our sex. They ask us to choose our ages. And by so doing, we are storing values. So if they ask of my name, I'm going to say Bob or Robert, and they will save my name in a container called name when they are referring to me. When they open that container, they find my name. Very simple. Now, when they ask of my sex, I choose M or male. And so male is going to be in a container called sex. The computer does what it does to also remember the details. So in a computer's memory, this is basically what happens. There is a bucket that stores your name. After they ask you, please enter your name. Fill in the following boxes. Now online we have used Google Forms and those stuff. So we are very familiar with all these things I'm talking about. The moment you fill in your name, first name, surname, sex, they keep it in a container like this. All right. Now, this is a real world application of the variables that we just talked about. Think of a time where someone goes to the market and then purchases 3 hockey sticks at a price of 180 cedis. After the person does the purchase, the person doesn't know how much one costs. In the real world, we assume the price of that thing is a particular letter. In mathematics, known as a variable. And then by so doing, because we bought 3 of those items, we say 3 of the particular variable, which is x, as we usually do, is going to be equal to 180. So that thing that we do not know how to use, or we do not know its value, represented by a variable, and so we start the mathematics. In maths, that's what we do, and in programming, it is no different. All right, let's proceed. So I'm going to give a short story, and then with this short story, we will have a good relation. All right, this video may be a little long, but it's all for our own good. The short story is every computer will interact with a user each day, and then during the interaction, the computer is going to display a message or a prompt on a screen with which the user will have to respond with an input. Now, when the user responds with an input, his input is stored in a container, as we talked about the sex, the name containers, right? Now, these containers are known as variables. The values in a container will be in a container for as long as you are interacting with that particular program. So when you close your Microsoft Word, all the items that you typed in there will go away because those items you typed in there were stored in a container. All right. The next thing is the data we give to the container or the computer is going to come in various forms. When they ask of your age, you are going to enter a number. When they ask of your name, you are going to enter text. A number and text are two different things. One is made up of alphabets and the other numeric data or numerical data. Before we can use a variable, we need to reserve a space. So let's say you meet me on the way and then you would want to ask of my name. Because you would keep my name, you would need my face. So anytime you see my face, you remember, oh, okay, so this container I open, I find its name. So you first have to get a container, and that container you want to keep my name inside. So you have to get a container that is used for storing names. If you want to keep my phone number, you will have a special place. You keep my picture on it, on that container, and then inside that container, you are going to have my number. So we have different buckets or different containers and what they store. Think of a time you go to the market, and in the market, you want to buy a container for storing sugar. I'm not sure you are going to buy a big bucket or a poly tank. No, you are going to buy a small container which is either transparent glass container. So you see, oh, this is sugar. That's basically what happens in the computer world. Now, we spoke about variables and how they are used. But think of a time where you visit the market again. Now, in the market, you go to buy a bottle. A lot of the times in our local markets, after one is done drinking the Baltic mineral water, they give it to the women at the market and they put oil inside. So you go to the market, you see the red oil, but the red oil has a label Verna mineral water or Baltic mineral water. That is basically wrong approach to naming the palm oil, right? All right, so in the programming sense, we have a way of naming a variable. When I talk about naming a variable, I mean the labels on top of the containers that will be storing our values inside. All right. So the first rule for naming a variable is a variable must not, a variable name must not begin with any other thing except the one you see on the screen, which is either it starts with an underscore or an English alphabetical letter. 2. A variable must not be a reserved word. By reserved word, this is what I mean. When you visit the church, there's only one person we refer to as Jesus. If you go to a church and you have two kinds of Jesuses, then you'll be wondering, where the hell am I now? There are some people we refer to as reverend in a church. So when you go to a church, no one will be called reverend except they indeed are. So there are some names that are reserved for specific purposes. I'm not sure you will name your variable table. Okay. I'm not sure you name your variable table if table has been reserved for a particular usage. Let me use this example. Even in a church, I like using the church examples because that's what I usually relate to. In the church, there are some seats that are reserved for some people. So you can't use those seats just for any particular person. Okay. In the kingdom of God. Yeah. Now let's come back to the programming sense again. There are some names that we cannot put on labels. Okay. We cannot put on on labels of containers. What are some of those names? When we begin, you will get it. All right. So I talked about reserving particular words. The next one is 3. And it says that the labels on those containers that we'll be dealing with has to be short and meaningful. When I started this video, I talked about the fact that we have pictures on containers in our memory. That is when we are dealing with a human. But what about you not dealing with a human per se, but you are dealing with an inanimate something? Think of a smell. Someone is cooking palm nut soup and the smell just passes through your nose. And right there, I'm not sure you can put a smell on a container and then put the name of that particular smell in a container. It was an example to get you on the part I wanted. So in the programming sense, just like the containers or the plastic bottles that we've seen, they have labels on them. And inside the labels, we have the content, what we'll be dealing with. So in the programming sense, I spoke about the buckets for storing the name. Under the buckets was written name. and inside the bucket had the name, had the text Bob. So that is what I mean. The name of the bucket should be short and meaningful. No name on a bucket, by so saying I mean a variable, should contain any of these symbols listed. By saying any of these symbols, I mean special character. Any symbol that's not an alphabetical letter or an underscore should not be used in a variable name. So the full stop, the less than, the question mark, the space, all of those are special characters because they are not part of the underscore and the English alphabetical letter space. They are not valid for naming a variable. After starting with an underscore and English alphabet, you can bring in a mixture of numbers, but a number can never start a variable name. The last one is what I just explained. So you can bring in a mixture of characters, but take note, the special characters are not part. We have several ways of naming a variable. You can name a variable just like on screen, where we have name of student. A name of student is a variable describing what we'll be keeping inside. In this case, name of student is a container that will be keeping the name of a particular student inside. This is from someone's program. But take note of how the variable name has been written. They started with a small letter. The next word, because the variable name is made up of multiple words, they started the first word with a small letter, went to the next word starting with a capital. All the rest of the letters in that word goes to small letters. The next word starts with a capital and all the rest are small. So this type of writing is known as camel casing. All right. Then the next one is known as the Pascal casing. The Pascal casing, every letter of each word in the variable name starts with a capital letter. And then the rest, every first letter in each word in the variable name starts with a capital and the rest are small letters. The final one is all small letters, but each word is separated by an underscore. All right, we're bringing our lesson to a close, but before that, there are some few more slides. How do we name a variable? We've spoken about the rules in this slide. We said it should start with an English alphabet, shouldn't be a reserved word, should be short and meaningful, shouldn't have a special character in there, and it should be a mixture of all the elements that are valid. So on the screen, I would want us to check whether the following variable names or the labels that we'll be putting on the containers are valid or not. The first one is lambda. Lambda is a word. Whatever it means, we don't know. But is it valid to use lambda as a variable name? Now, to check whether it is valid or not, try and see whether it violates any of the rules that we talked about in the two previous slides. When we look at lambda, it starts with an English alphabetical letter L, continues with a mixture of English alphabetical letters, and it sure looks valid. Now, let me talk about the reserved words. I spoke about reverend as a word in the church. We cannot use reverend anywhere outside the church. Hold on. All right, so the word reverend is reserved. Now, in a lot of the programming languages that we talked about, they have words that are reserved. We cannot use those words in naming a variable. That's basically what a reserved word is. In a language like Python, lambda is reserved, but the lambda that is reserved or is used for a particular purpose starts with a small letter, not a capital letter. So for the first example, this is valid. Now, the second example, it is not valid because it starts with a number. And with a number, it's not part of the first rule that we gave. It should be an underscore or an English alphabetical letter. All right. The next one starts with an English alphabetical letter, all right, but it has special characters with respect to the space, the full stop, and so it is not valid. The fourth one is valid because it starts with an underscore and all the rest are English alphabets blended with a mixture of the underscores, satisfying the rule 5. The fifth one is not valid because it has a special character starting and it is not an underscore. The sixth is not valid. In languages like the PHP, it is valid, but in the general sense, it is not valid because it disobeys the rules that we spoke about. When is valid? Because for now, we don't know any particular programming language that reserves the use of when. But the word while is reserved in a lot of programming languages, and so it is invalid to use while as a variable name. But come to think of it, who at all will create a variable and name it while? Which container in the world is going to store something called while? Well, that's just by the way. But looking at the rules that we just learned, while is invalid because it's a reserved word. If is also invalid. Date of birth is valid, satisfies all the rules. The next one is also valid. This is valid. Name 2 is valid. Surname is not valid because it has a space in between it. The next one is also not valid because it has a special character terminating it. So these are basically the rules for naming a variable in programming. Now, we spoke of the fact that when you go to the market and you see a Baltic bottle with palm nut soup inside, or red palm oil, whatever they say, inside it, then whatever is inside that container is its content, right? Now, in the programming sense, any bucket has a particular type of data that it stores. And in programming, we have basically 4 types of data that we store, basic types of data. The first one is a string. The next one is a number. The third is a character. And the last one is a Boolean. What is a string? Let's find out. Now, a string is any type of data that is made up of an ordered sequence of characters. Now, you will ask, what's a character? Character is just a symbol. So we have the A, the letter B, the letter C, the letter D. The hash symbol, the pound symbol, the ampersand, the caret sign, percentage sign, all of them are symbols. And those symbols coming together to form a series of characters would create what we call in programming a string. All right. I don't want this to be a lecture, but because I'm following the slide, it will sure look like one. But if you have any questions, you write them in the comment section or interact with the instructor via the mail in the last slide. Now, another type of data we can keep in a container is a number. So when we are dealing with a number, we are talking about numeric type of data. Now, all numeric type data are known as numbers, okay? And so with a number, we are talking about decimals and integers. Let's go back to the string. In programming, in a lot of languages, by referring to a string, we have a word like programming languages. It's a lot of characters coming together. So programming over here is a string. In programming, when we are writing our codes, we put double quotes here around anything that we refer to as a string. We'll see examples in the coming slides. For a number, we don't put quotes around the number. All right. A Boolean is big. Let's find out. any type of data that is either true or false is a Boolean. So if someone asks, "Are you a male?" and I say, "Yes, I am a male," it means that I responded true to the question. Well, the person asked the question taking one side. The bag is big, and I say, "Yes, it is." I'm saying it is true. She is dark, and I say, "No, she is not." I am feeding false as my input. So that is the Boolean response. Okay. So a Boolean type of data is either true or false. Now, a character. What is a character? In programming, any symbol is a character. And a character, the word, the article "a" tries to tell us that we are dealing with one item. So you cannot have two letters standing together like over here and say TO is a character. No, T is a character. The O coming to join the T creates a string in programming. All right. In a lot of the programming languages, they put single quotes around characters and they put double quotes around strings. On the screen, we will find examples of the data types that we talked about. We spoke about strings and we said that in programming, we always surround strings with double quotes. So we have Sandra on the screen, my favorite example. And we have Ghana also surrounded with double quotes. We have my phone number on the screen there, also surrounded with double quotes. Those are strings. I'll come to a number. A number is any item that is numeric. So 1, 2, 3, 4 is a number. It is not surrounded with a double quotes. It can be a decimal, so 50.6 also a number. 99.2 is a number. 5/7 is a number. 20.333 is a number. Now 5/7 is going to get evaluated to a particular value. And that value is a number. That's basically why we see the expression over there. A Boolean, which is anything that's either true or false. All right. So the examples of a Boolean that I can give is just the true or the false. Now, talk about true or false. They are reserved words, and so you cannot use true or false to name a variable. All right. The next item we talk about is a character. Character is any symbol that is surrounded with single quotes in programming. When I say any symbol, I mean just a symbol. So let's proceed. This is where we are going to end. And by ending, I mean we are done with the lesson talking about variables. We are to write 10 variable names following the rules that we gave, not the data types. 10 variable names following the rules that we gave for each data type. All right. Now, I would want to give us a clue, and so I'm going to do a little demonstration. For the data type string, which variable names are you going to be using? So if you are going to store the name of someone, then store the name in a variable name that gives you an idea of its content. Okay, so let's go back and take a look at this screen. All right, so on this slide, we see a table with a few examples as was asked of us. Now we are supposed to write 10 variable names under each of the data types. On the screen, we have about 10 spaces. I've filled in some, so do fill in the rest. The first data type we talk about is a number. Which variable name would you create to store a number? Now, if we are dealing with a person or we are writing a program, we would want to store the age of someone in a container so we can interact with it at a point. I'm sure you are going to come back to the video after we start writing programs in order to understand variables the better. So we would need to reserve a container. So we create a container in memory, name that container age. And because the name is age, you know you are going to keep a number inside. That satisfies the third rule, which says the variable name should be short and meaningful. So by seeing age, I know I'm going to keep a number inside. By seeing height, I know it's going to be a number I'm going to keep inside. All right, let's go to the next one. When we are filling forms, we have spaces that we need to take sometimes. And when we are talking about the blood group of someone, it's going to be a character. It's either it's blood group A, blood group B, blood group B, blood group O. We have one that's AB. We can represent a particular letter for that particular one. So if we are creating a variable or a container to be storing symbols, then I think the blood group is a particular variable name that we can make good use of. Size. Sometimes you buy a shirt and then inside the shirt they've written small, large, medium. And usually they use letters, single letters to represent those stuff. So we have size. One that is M is for medium. So if you are creating a variable name to store items like that, then it's going to be a character. So I want you to create examples of variable names, which after seeing, you will definitely know, oh, okay, this one has to be under character. This variable name has to be under string, because we've spoken about what they are. You can visit the data type table, and by visiting, you'll see the kind of content, the items with which I used, and so you will have a lot of examples to play with. A string is another type of data, and a container, which is a variable name, that you will see, and it will be so obvious that the content is going to be a string. An example is the color of shirt. You can see I never brought a space in my variable name. All these things we are seeing on the screen are variable names and they are valid. Color of shirt. Color of shirt is a variable name I gave for a container that's going to be storing a string. Name of parent. Name of parent is a string because the content or whatever the user is supposed to keep inside is made up of a lot of characters. The last column we have to talk about is the Boolean. When you are naming a Boolean variable, make sure that it is one-sided so that the user has the chance to either say true or false. An example is has eaten. Has eaten has already taken one side, claiming that the person we are dealing with has eaten. So by saying true or putting the word true in that container, we are confirming the fact that the variable is taking one side, which is now saying has eaten. Is married. Is married is claiming whoever we are talking about is married. So by putting in true or false, we are confirming or denying. That's where we are going to be ending. When you are done with your assignment, send it to this mail. Stay tuned for the next session.